Hey, I'm trying to build some electronics, and I'm trying to use this MOSFET as a switch. But the problem is, I want to turn this MOSFET on using an Arduino. So MOSFETs are like switches, right? So you can close them by putting a voltage on the gate terminal. The problem is, to really turn a MOSFET like fully on, like super conducting, to be like super like conductive with like low resistance, you need to have the gate voltage around like probably like 10 to 12 volts, I think, is like the ideal range for most MOSFETs, I think. So the problem is the Arduino operates on 5 volts. So if I say like Arduino like turn on, like go high, this will only go up to 5 volts. But I need to have the gate of this MOSFET at like 10 to 12 volts. So I had a problem, and this video is like the solution of how I solved this problem. So like I drew up a quick circuit just because like I've had this problem for a while, and I was having difficulty finding a solution that worked. So I'm just gonna outline this for like everyone out there. If you're looking to figure out how to generate like a 12 volt PWM signal from using an Arduino. And the key really is to use opto-couplers and to use a like external 12 volt wall plug supply. So basically what happens, like as an overview, is the Arduino sends in like a 5 volt pulse signal here, and these opto-couplers isolate, like they basically keep all the 5 volts on this side and they keep all the 12 volts on this side, but they convert like the PWM signal itself using the switching on and off between these two opto isolators. So like I send in a 5 volt pulse signal in. When it's high on the Arduino, it'll turn on the bottom opto-coupler, and when it's low on the Arduino, it'll turn on the top opto-coupler. So basically, essentially this is going to be like kind of the 12 volt PWM like node. Like this is where the 12 volt PWM signal is going to come out of, and it's generated by connecting this node up to 12 volts through this opto-coupler when this one's turned on and this one's turned off, and then bringing it down to 0 volts when the reverse is happening. So when this opto-coupler is on and these are connected, it'll be at 0 volts, and this will be like disconnected. So it'll flop between these two voltages basically. Yeah, so that's how I did it. You'll just need a pair of 2 opto-couplers, and yeah, and that will help you transfer the 5 volt PWM signal to a 12 volt PWM signal output. Now another challenge is you need to maintain 12 volts here between the top opto-coupler input and like the bottom opto-coupler. So I just found like this old phone wall plug over here. You can buy them usually like any Goodwill, any like thrift store is just gonna have like the electronics section. You just go to that electronics section, and like on the bottom somewhere, it'll have like an output rating. So like just look for that where it says output, and then you want like DC 12 volts, and that'll be really good. That'll be good to turn on your MOSFET, that DC 12 voltage. So we have the 12 volt. So basically what that wall plug is doing is it's creating 12 volts across this top of the opto-coupler and the output down here. And like this schematic shows like how they're like connected. So you've got the bottom, basically there's 2 wires that come in from that plug. I have the bottom wire connected down here and the top wire connected up here. And then basically in parallel with that wall plug, I have 2 capacitors that also kind of connect to the bottom down here too. So the capacitors just like help that wall plug by holding its charge, holding that voltage, holding the 12 volts, just so I have like extra energy to help like pull this up to 12 volts, and then I don't use up all the energy when I pull it down to like 0 volts, and then so I can just keep pulling it up and down really fast, like high frequency. And then the last thing is I have a diode here to kind of prevent any of that like current from flowing backwards, just to make sure I maintain those 12 volts, and it doesn't like the energy I use to charge the capacitor doesn't like just leak back into the wall plug. So yeah, so this circuit schematic will reliably give you a 12 volt output PWM signal. And then the last component I have in here is I needed to actually, when I first built this, I didn't have a resistor between the gate and the source. So the output of the two opto-couplers, and then kind of the bottom, the ground rail, basically, the bottom of the 12 volts. I needed a resistor here to like basically help the PWM signal drop to 0 faster when I cut off this optocoupler. Otherwise, rather than having like a nice square wave, it just kind of like sagged down. So having this resistor here will help like pull the voltage down quickly and give you a nice square wave output. So again, this is creating a 12 volt signal so that I can drive the gate of a MOSFET, so that it'll turn fully on and fully off really nicely. Yeah, so that's the circuit, and that's the schematic, and I'll just show you like kind of like the circuit just so you can kind of see how it's wired up. So I just have like I have a potentiometer controlling like the duty cycle of like a PWM signal, and that output, or the PWM signal comes out, and it comes in here to the two optocouplers in the middle. So when the PWM signal is high, like 5 volts, no current's not going to flow through this top one because they're both like 5 volts. There's no potential difference. There's going to be no current flow. But this bottom is always grounded, so the current flows through, conducts through this diode, and then this side will conduct, turning on this optocoupler. So yeah, so these two little things are the optocouplers right here. They are PC, let's see, let me look up that part number that I used. PC817s. PC817 optocouplers. Yeah, so then the high voltage comes over here. This is where my like wall plug comes in. There'll just be like a red wire and a black wire. I just have those here coming to the board with the diode, a little LED just to show like if there's like power plugged in, like if the wall plug is plugged in, that's what the LED is for. And then I have some capacitors just to kind of help hold the charge. And then I have these two wires coming over to my MOSFET. So the great thing about having this wall plugged, like just connected down here, is that I can connect the gate here and the source to, or the bottom of my optocoupler circuit to the source pin. So the reason this is good is because even if this like source pin is at 12 volts, because the ground of the like supply is always connected to this source pin, even if the source pin goes up to 12 volts, there's going to be like a positive voltage increase over the supply, this wall plug. So it'll hold this at like 24 volts. So no matter what the supply is, like you're always going to have 12 volts between gate and source, which is like what you need to turn on the MOSFET well, like fully on. So yeah, this video is getting kind of long, so I'll wrap this up here. Here's the like circuit schematic. I have the Arduino on at 5 kilohertz right now, I think. So you can see the top is a 5 volt input. Both the scope is set to 5 volts per division for both of them. So you can see the input is the 5 volt there, and then the output is that 12 volt. This is the gate driving signal here. So you can see they're both at the 5 volts up there, and you get a nice 5 volts in, 12 volts out. It's a little bit distorted, but it's definitely good enough to work. And I actually have it running a MOSFET right now, and it's just dumping all of its energy across this big old power resistor here. And you can see as I okay, so the duty cycle is super low here. As I increase it, you can see over here the current rising as I increase the duty cycle. And none of these devices are really getting hot. Like this MOSFET here, let me just feel it real quick. Oh yeah, that's cold to the touch. So that's how you know it's really turning on. It's not just turning on a little bit. It's really conducting well, not generating a lot of heat. So boom, that's how you do it. Create a 12-volt PWM cycle using opto-couplers and a 12-volt wall plug and some capacitors and like resistor and stuff. So boom, here's the circuit. It works. Test it out.